so that was hard.
Alright, so we start off with a series, and I wanted to go through the test from yesterday, just to kind of remind you, and then do 2 more. So. Oh yeah, we wrapped yesterday. I did. I have yours and yours. What? You were too?
It was 2 days ago. Yeah.
Sure. I gave the test back whenever.
Well, it wasn't yesterday.
We have to go over it.
We did.
I didn't.
No, we don't just do a real test together.
Okay.
Where? There?
Would you, actually, you know what? Forget it. Would you take a minute and try A, B, and C?
Yeah.
Try them.
A, B, and C.
Look at your notes. See if you can figure it out.
Did we learn them after I left?
Yes.
Yeah. You missed the big, exciting thing.
Do that then.
You missed the fun fact.
What's the fun fact? It was so, she got so excited.
That is.
Wait, did you post it on YouTube yet?
Yeah.
I'll watch it.
No, I didn't actually. I can do it today.
Oh well. We got a worksheet. The first one says take a series of these.
I love when you film because Zach's terrible. He goes in like circles purposely to make people sick. It's so annoying. Alright, try the first 3 and we'll go through.
Yes. Take the series of the sum of e to the negative n from n equals 1 to infinity and show that it converges using
No, the
a
integrals test is basically the test.
nth term test,
We didn't do it
the
yet.
test for geometric series, the integral test, and since we haven't gotten to it yet, the ratio test.
She's explaining to the viewer
What is on the worksheet that
happening.
is really blurry when you try to film it.
Alright, fine, we'll do it together. Alright, let's do it together. So, take this series. Alright, a couple things. First of all, when we do these tests, if you have an opportunity to write something as a fraction, it usually is helpful. So even though this is given to you like this, it's probably going to be easier. Oh, look at that marker. If we rewrite it as a fraction, look at it that way. So what I wanted to do is just show you that one series can be analyzed using different tests, and you're going to get the same result. So for part A, we're supposed to use the nth term test to decide if this series converges or not. So the nth term test is what we did yesterday. We said we look at the limit as n approaches infinity of just the series itself. And the idea was if the limit goes to 0, then what does that mean? Nothing. If the series, it could converge. If the series doesn't go to 0, then it definitely diverges. Well, for this one, what does that go to when I look at the limit? 0. So it's inconclusive. It means the series may in fact converge, but not definitely. It's not a guarantee, it's just a possibility. Okay, part B. Let's look and see if this is geometric. Is it?
Yes.
Yes. Okay, if I'm not sure, I start getting a couple of the first terms. If I plug in 1, I get 1 over e. When I plug in 2, 1 over e squared. Plug in 3, 1 over e to the third. Blah, blah, blah. So the multiplier is 1 over e. And what does that have to be less than to make it converge? 1. Is 1 over e less than 1? Yes, it is. Okay, e is like 2, so 1 over 2 is less than 1. So yes, so therefore the series converges. So nothing new, just kind of like reviewing again so that you get into the mode of this stuff. Part C, use the integral test. And if you recall, the integral test says if we take the integral of 1 over e to the n from 1 to infinity. Actually, I should change my n to an x, because really we're looking at it as a function once we look at its integral, but whatever. So if I take the integral of that, if I can get that to equal a number, then the series will converge just like the integral does. And if I get this to equal infinity, then the series diverges just like the integral does. So they both do the same thing. So to rewrite this is going to be the limit as a approaches infinity of the integral from 1 to a. So I got to do that rewriting thing like you did on the test we did last week, or weeks ago. And I'm going to change this back to e to the negative of the x. e to the negative x. Even though I just said it's easier sometimes when it's fractions, sometimes if I integrate, I'm going to want to look at it this way. What is the integral of e to the negative x?
Negative e to the
Negative
negative
e
x.
to the negative x. Evaluated from 1 to a. Am I going way too fast? So, plug in, so I've got negative 1 over e to the a minus negative 1 over e to the 1. I put it back as a fraction, because it's like when I'm looking at it as a limit, it's a lot easier to look at as a fraction. When I look at it as an integral, that was just easier to integrate, not as a fraction. So it just depends on how I'm looking at it. And now I look at a going to infinity. So if a goes to infinity, what's the first fraction doing? 0. And then the second one plus 1 over e. So this equals 1 over e. Does that mean that the integral converged? Yeah. Yes. I got a number. So as long as I get a number and not infinity, the integral converged. So the integral converged, or converges. So therefore, the series converges. Blech. So that's basically what we did yesterday. Okay, we looked at this nth term test, we looked at geometric even though we already knew it, we looked at the integral test. What you guys missed, I'll just fill you in quickly because I know there's like 5 of you, is that when we do this integral test, there's a special case of 1 over x to the n. Wait, do I have that right? Yeah. Why is there an x?
1 over n to the p.
Yeah, because I don't want that to be an x. It's going to screw you up. Thank you. And we called it the p-test, and what we said was like, this is just like when we looked at it with integrals. If p is greater than 1, then the series is always going to converge. And if p is less than or equal to 1, the series is always going to diverge. And it's just a really handy little test. And you can go look at the video, but it comes from the integral test, but it's kind of a separate thing that you can just look at and know. And then we talked about this harmonic series, and this was the fun fact. Did anyone want to hear it again?
Yeah. Yeah, I know.
So this is called, if you just have 1 over n, it's called the harmonic series. And it goes 1/2, 1/3, 1/4, 1/5, 1/6, blah, blah, blah. And this is the smallest divergent series that I think that there is. And the thing that was so cool, I can't give it the same excitement because all the rest of you already know. When we add up these terms, for you to get a sum of just 20, it takes, what was it? 134 million? 179 million, more than 179 million terms to get a sum that goes above 20. But the thing diverges, which means the sum goes all the way to infinity, so it's like an insane amount of terms for it to actually get to infinity. Watch the video, it's better, because I have more energy. Okay, so now we're up to a new test called the ratio test. And the ratio test is really kind of cool. It's probably the one you're going to use the most. Beyond
Everything I missed yesterday.
all the thing you really miss is the p-test, yeah.
Oh, really?
Yep.
Yeah.
Yeah. And you miss my excitement and joy of the harmonic series.
So I'll make sure you
Yeah.
get that on.
I didn't do it justice just now.
No. We should, like, you got a video file. She was saying going, oh my god.
It wasn't quite the same.
That and calculator.
No one was filming that day.
I know.
That is.
Yeah, we were trying to look for
Just
that.
because.
Look at the audio.
No one wasn't filming.
Why not? That's, I think you stopped filming like right before you did that or something.
I don't know.
It's like has like it's stories.
Yeah,
So
like
we put
it,
a label saying we
And we
recorded
couldn't find the
it,
video that said
otherwise
that.
you're not allowed to have it.
You tried to look for it?
Yeah, of course we did. That's what makes my ringtone.
That's so funny.
This worksheet.
You're not. This should be in your regular notes.
I don't have my.
Is this gonna take up a lot of space? Or is this like a quick thing?
It's pretty quick. I'm gonna do this part later. Oh my goodness gracious.
Oh my goodness gracious.
Alright, the ratio test is gonna be like your go-to test after you've checked to see if it's geometric. If it's geometric, use that. Although the ratio test will still work. It's just that the geometric test is easier. What I'm going to do is I'm going to take my series and I'm going to take my n+1th term and put it over my nth term. And I'm going to see what I get when I take the limit of that comparison. And what I get can be one of three things. If what I get is less than 1,
How can you have infinity plus 1?
because you can.
Makes no sense.
If what I get is less than 1, then the series is going to converge. If what I get is greater than 1, then the series is going to diverge. And if L equals 1, then unfortunately the test is inconclusive.
Is that a sufficient answer?
No, then you have to do more tests. Then, then you have to check the sun, get a sundial. Kind of tired. So let's go look at e to the n, the one we were just looking at, to see what the heck this means. Okay, Mike, don't fall asleep.
Wait, you
I'm
didn't
awake.
I'm just checking.
I'm about to sue you. Ask Suyan.
Yeah,
I
I
was
know.
thinking last year.
Last period, Mike's over first.
Darren's paint or slipping in,
I
still
know.
obtaining information. I don't know how he does it.
What do you do that makes you so tired?
Not sleep.
Starcraft.
Food Boba.
Do you work late?
Not usually.
Stop calling out.
I'm just asking. It's definitely habitual, so I'm just, you know.
Sometimes I have lots of shit to do.
Yeah.
Just some drugs.
What's it?
Drugs.
Yeah.
Pre-calculation.
Well, I know he slept in pre-cal all the time, right? Yeah.
Well, that class just sucked.
Right, like,
class blew.
okay, you know what? Shh.
Wait, she's not
I'm still gonna draw my
That's a
face. It's
video.
gonna happen.
Wrong film.
I'm sorry.
That's okay. Alright, how this works is like this. The ratio test says we're going to take the n+1th term and put it over the nth term. So all I'm going to do is I'm going to take this series and write it as 1 over e to the n+1 over 1 over e to the n. This is the setup of what I'm being asked to do in the ratio test. The ratio test says, look at my n+1 term and look at my n term and put one over the other. So that's what that means. Just go take all the n's, make it n+1s, and then put it over the regular series notation. So for each one of these, you're usually going to have a flipping and multiplying. So if I were to rewrite, I'd have 1 over e to the n+1 times e to the n. So,
Are we gonna be able to just kind of jump to that step, or are they
Yes.
gonna want to see that?
No.
in there?
Usually I'm going to write it already flipped and multiplied.
Okay.
Okay, but we'll get used to that. So I gotta take the limit now as infinity, n goes to infinity. So I have like infinity over infinity kind of, but I can actually reduce this. What's that?
It's a bigger infinity.
It is, but it actually doesn't go to 0. Because it's, yeah, like,
Whoa.
it's not enough bigger. It's not enough bigger. That little +1's not enough. Just like yesterday in that example when the 1 had like a 6 with it, like that's not enough to make it really change. When I have the same base in different powers, how can I rewrite this? Yeah, this is e to the n minus minus n plus 1, I can take my powers and subtract. When I use ratio tests, a lot of times what I get is going to reduce. So if you can reduce it, reduce it. If I've got the same base, I can subtract powers. So what I'm really looking at is e to the negative first, right?
So we got another.
So we did, I got 1 over e. This equals the L that I'm talking about. So the rule says, put 1 over the other, the n plus 1 in the n, see what you get, and whatever you get, if it's less than 1, the series converges. If it's bigger than 1, the series diverges. If it equals 1, the test is inconclusive. So, it's less than 1, so the series converges. What'd you say? Oh, I know.
So, does that mean it converges on all real numbers? Or
This one in particular, yes.
so even if the ratio test, will the ratio test give you a number like that for geometric, or will
Yeah,
it?
because this series is geometric.
Oh, right.
Yeah.
But, so, even the ratio test can't tell you the interval of convergence?
What it's going to do is, once we have an x in here, which is we're going to do on Monday, we're going to get down to here, and it will find us an interval of convergence.
Okay.
When there's an x.
Okay.
When there's an x. Okay, so, let's go same worksheet and let's do another one. Take a second, and can you try number 2 and number 3? Please.
I can try, but it won't.
Start with the nth term test, and then skip to the ratio test after that, just to practice this one. So number 2, try the nth term test, and number 3, same, and then skip to the ratio if the nth term is inconclusive.
Number 2 says, does n sine of 1 over n,
It's just confirming with me, I'm like,
That's why I didn't follow this.
sorry, no, it's good. I thought you were like confirming it with me, so
no. You know, unless you want to write it on the board.
Oh no, it's not infinity actually. Number 2 is actually a little hard. Can I give you a hint for number 2 before you really get too far?
Actually, could you just write the problem on the board?
Sure. So it's the series n times sine. You might think, if you look at this and you try to, guys, can you stop back there? You try to look at the limit as n approaches infinity, and you think like, well, this is infinity, and this is the sine of like 1 over infinity, so like, what 1 over infinity is what? Kind of, it's 0, right? So the sine of 0 is 0. Which one wins, infinity or 0?
Infinity's pretty big.
0 doesn't win.
Anything times 0 is 0.
It means we need to look at this differently. It's actually a type of the indeterminate form that we don't really talk about or see very often.
Anything times 0 is 0. Not quite 0.
Well, we can't do L'Hopital's yet because we don't have a fraction. But what we can do is create a fraction. What I can do is, sine of 1 over n is one term. What can I divide sine of 1 over n by? Is that I have an equivalent expression, but I have half a fraction. 1 over n. Yeah, 1 over n. So I can create a fraction out of multiplication, and then, if I plugged in infinity, I'd have 0 up here, because I'd have basically the sine of 0, and 0 on the bottom, and then I can use L'Hopital's. I know.
That's awesome.
Right?
Wait, not quite.
Let's just go through that one more time. If you have a problem like this where it's really kind of unclear, like I have infinity times potentially 0, that is an indeterminate form we just haven't really talked about. Try creating a fraction out of it. If I have a multiplier, divide it by the reciprocal of that. And you then created a fraction, and then you see you've got 0 to 0, you can use L'Hopital's. If that makes any sense.
What's the rule of fractions inside of trig?
I gotta take,
You just chain rule.
I have to use chain rule. cosine with respect to 1 over n times the derivative of 1 over n.
So just negative 1 over n squared.
Awesome. And then on the bottom, I also have negative 1 over n squared, and look at what happens.
Oh my god.
Now, the negative 1 over n squared and negative 1 over n squared cancel, and the cosine of 1 over infinity is the cosine of 0, which is 1.
Yeah. OMG. Oh my god.
And we said that using the nth term test, if the limit is not 0, if it's anything but 0, it diverges. So this series, whoops, wait,
Oh, right.
diverge. Right, so this is
Raise your wallet.
the only test that it has to equal 0. If it's anything but, it's divergent. So there's the nth term test. So like you're done. You don't have to do anything else with this,
That's exciting.
right? All right, second one.
Oh my god. Can we just make a guess?
Number
Smell
3.
like smoke.
They're doing a controlled version.
There. Oh wait, dude. I forgot to spray my shoes.
Febreze.
Febreze.
I was like, I remember Febreze in H1 day.
The bottom goes wash off some. You smell
Yeah. So think about this.
I don't do that.
It's inconclusive.
No. You smell different.
Number 3. Oh my gosh, what is everybody?
It's nice outside.
It's
It's
cold.
You brought
Nice outside.
You played frisbee. Yeah.
Any, on the bottom, n equals 0.
Retard
What?
N equals 0.
That's okay. Then you look over me.
Yo,
Reminds
who's
me.
not going to the Hunger Games?
I'm not.
Who's trying to go to the beaches instead of going to school?
No.
No. So cool.
I don't know why not.
All right, ready? Listen.
Day.
If you try to do the nth term test to this, let's just think for a second, which is growing substantially bigger than the other?
Bottom.
Bottom is growing much faster, and if we did L'Hopital's rule, we'd get there eventually, because when we kept taking the derivative, this would eventually come out to a constant, right? N to the 10th would be 10 n to the 9th, and then it'd be 90 n to the 8th, and you go all the way down to a constant. So we would eventually get to the point where the only place that was growing was the bottom, and the top was a constant. You don't have to keep doing that, but you can know that the nth term test is inconclusive. Okay, the nth term test is going to equal 0. So because it equals 0 and not something other than 0, it could converge. Doesn't definitely, but it could. So let's look at the ratio test. So again, the ratio test says replace all of my n's basically with n plus 1's, put that on top, and then put the regular series on the bottom. So I'm going to look at the limit as n goes to infinity of n plus 1 to the 10th over 10 to the n plus 1. And I'll write it as a fraction again, but then I'll probably start just flipping it right away. N to the 10th over 10 to the n. All of the ways will work, but like that's not really going to be able to be integrated, so you're not going to use the integral test. So, you know, it just, the ratio test is the one that works most often. But sometimes this doesn't either, because if L equals 0, then this is inconclusive, and you got to use another one.
Wait, on the test for this, are we
Oh,
gonna?
I'm sorry, if it equals 1. Sorry.
We have a ton of time
On
on
the
this.
test for this, are you gonna tell us which test to use? So we can pretty much just go to the ratio test if the first.
I would go nth term test first, ratio test second, and then go start scrambling to look for other stuff.
Geometrics test.
Oh, and geometric. Yeah, no, geometric. I would go nth term test or geometric first, and then go ratio, and then go look at the others. Alright. There was 2 from yesterday, and there's going to be 1 more today in a second.
Yeah. I wonder how that goes.
What?
Yeah. Like right now.
Alright, the thing with the ratio test is stuff is going to reduce. I am seriously mental when it comes to this, so I will show you what I have to do because I'm mental. I need to like pair similar things over similar things. So like n plus 1 to the 10th over n to the 10th I need to put together, and then 10 to the n over 10 to the n plus 1 I need to put together.
I get it.
Okay. Oh, isn't it nice of you to drop by?
Where were you today in study hall?
Everybody missed you.
Seeing a play. It's great.
What play?
I'm just gonna say.
I don't even know what it was called. Travesties. Don't know what it's about. No idea.
Okay. So anyway, I'm going to reduce. I don't know what you just said. This can't get reduced, okay? I don't have the same base or anything, so I can't reduce this at all. I'm going to need to leave that as is. But this can, because I have the same base, I can reduce it. So 10 to the n over 10 to the n plus 1 is 10 to the n minus n plus 1. So it's similar to what we did. So it's 10, it's 1/10, right? And now if I'm looking at the limit as n approaches infinity, I just have to be a little bit like rational about this. If this is n plus 1 to the 10th and this is n to the 10th, is the top really growing faster?
Slightly.
Slightly, but like in the grand scheme of things, not enough. This is behaving like n to the 10th and this is behaving like n to the 10th. They're really behaving like the same thing. Just because this has some other terms, it doesn't change it as I go to infinity. It's like yesterday, I forget what it was, but what, like 6n to the third over n squared plus 1? Or no, it was the other way. Squared, and this was to the third. We said this behaves like 1 over n, right? We could get rid of like this superfluous stuff and just basically look at the highest degree and the highest degree. With polynomials, I don't need to worry, I need to just worry about the lead term on the top and the lead term on the bottom. So, because this lead term was n squared and that was n to the third, reduced to 1 over n. This lead term is going to be n to the 10th and n to the 10th on the bottom. So it's just going to be 1. As n goes to infinity, they're behaving the same, so it's just going to be 1. And therefore my total limit is 1/10. And that's less than 1. And the ratio test says if what I get in the end is less than 1, then the series converges.
And we're done. Oh my goodness. That's a long
I didn't say we were done.
What? We did.
We can go better.
That just came back. We're done.
I got one more test to show you.
No.
Yeah, I know you don't want to hear it, but I'm going to show you one more. We won't even do a problem with it, but I have to show it to you because I just want to be done it.
Why do you have to show us?
Because it'll come up eventually.
How about we do that's the only thing we do tomorrow?
It'll take like this much and it makes sense.
Wait, we don't do anything tomorrow then, right?
Tomorrow we're just going to be working on problems.
No, you said nothing tomorrow. Why can't you just say
That's
free tomorrow? Taboo Friday. We haven't done that forever.
We haven't played Taboo in so long.
I know.
I'm not writing taboo on my neck.
Here's what we're doing. We'll do this. I'll tell you what I'll tell you what the assignment is, and then it's due Monday. We'll go over it on Monday. So whether you do it in class tomorrow, or you do it at home over the weekend, or whatever.
Or what about option C?
There is none. Okay. Direct comparison test basically says this. I'm going to say it in normal words because it's going to make a lot more sense. Instead of writing it all up all fancy. Shh. If I can take a function. Okay, let me see if I can put this in good words. Let's say I have my series. And I want to show that it diverges. If I want to show that my series diverges, if I can find a function or a series that is smaller than my series that diverges, then by comparison, I can say that mine diverges also. Let me say it again.
So you
If I want to show that my series diverges, I can find a known series that I already know. And as long as that series is smaller than mine and diverges, then mine's going to diverge too. Does that make any sense?
Yes. So would you compare it to always to 1 over?
I'm going to I could compare it to 1 over n because I know that 1 over n diverges, so if I can find a series that's a little bit bigger than that, for example, like if I have 1 over n, right? No, I'm sorry. If I'm given, I'm going to be bad. Okay, let's say I'm given n squared over n. This is stupid. Whatever.
That's n.
Yeah, I know. So it doesn't work. Okay. N squared plus 1, but still, yes, that's going to behave like that. But let's say I'm given that. Because we know that the series 1 over n diverges. And the series I just found is even bigger than this because I put stuff in the numerator, so it's bigger than it. Then mine diverges also. Do you know what I mean?
Yes, I got it.
But if
No.
I feel like that doesn't always work.
Well, because the idea is, think about, if I know, they say this is 1 over x, I know that 1 over x diverges. Well, if my series is even bigger than that, then mine has to diverge also.
Oh, okay.
That's what it's saying.
So pretty much if it has a degree in the numerator greater than 1, or
That's-
greater than 1 more than the bottom degree.
Well, yeah, but not necessarily. I mean, this is just if I'm going to compare it to this, but I can compare it to anything. Let me, it works also conversely. If I want to show that my series converges, I want to find a series bigger than mine that I know converges. And that's enough of a comparison to know. So if I want to show that my series converges, I want to find a bigger series than mine that converges. That's really sloppy. Okay, so like the idea of it makes sense. What's hard about this is the problems for this are like ridiculous. Really quickly. I know, shut up. If I had this.
That's on camera. You have to say you do not say shut up in your high school. Like Lamont said. Shut up.
If I had this, I can compare this to 1 over n squared. We know that 1 over n squared converges, right? By the p-test, we know that 1 over n squared converges because the power is bigger than 1. And we know that 1 over n squared is smaller, no, is bigger than the series I have. So therefore, my series converges also.
That easy?
Yeah.
Can you just
Tell us the biggest series that converges and the smallest we can use those forever.
I don't have the biggest.
Probably.
I know, well,
Because I feel like if we know the smallest series that converges and the biggest series, we can just answer every question with those.
Yeah, but they could look totally different. And it,
But it doesn't matter because they're bigger or smaller.
yeah, it doesn't quite work like that.
So can you give us an example of two that are convergent and look different?
We'll come across them as being problems, so you still know me. Hi guys.